Okay, in math, we're on chapter 3, lesson 4, and we're doing equivalent fractions and mixed numbers. For some of us, it was a mouthful. It's all review from 5th grade, but if you didn't really get it in 5th grade, we moved pretty fast through our review in order for you to relearn it. It'd be pretty tough. So we'll be doing more review in class, not to worry. So I need to write an equivalent fraction to 12/20ths. A couple ways I can do it. I can multiply them by the same number. We did folds in class, so we folded a piece of paper in half, we shaded half. Then we made more cuts and folds. And then we said something like, okay, 1/2 is the same. Now I have 1, 2, 3, 4, as 1, 2, 3, 4/8 is shaded in. I started with 2 pieces with 1 shaded in, ended up with 8 pieces with 4 shaded in. Equivalent fraction, it's the same amount. That didn't change, just the way I represented that amount. So 2 ways you can do it. You can multiply the numerator and the denominator like we did with the paper, making more folds. 20 times 2 is 40. Have a paper that's folded into 20 pieces, now folded into 40. 12 are shaded in, and then with the same amount of folds, 24 would be shaded in, 24/40ths. You can work the other way. You can divide too. So 12/20ths. If you can simplify the fraction, you can say, what can both 12 and 20 be divided by evenly? Preferably the greatest common divisor. Look for a divisor of 12 and a divisor of 20. Well, they both can be divided by 2, but they can also be divided by 4, and that's going to give me my simplest terms. 12 divided by 4 is 3. 20 divided by 4 is 5. Well, I've just written 2 equivalent fractions. You only had to write 1. And most of the students just divided each one by 2 and got done with this rather quickly. So they're probably interested in different problems. Let's take a look. Are these 2 equivalent? The book recommends simplifying them. If they're equal and if they're represented the same in their simplest terms, they're equivalent. So, can I simplify 6/8? Well, can I divide both 6 and 8 by evenly? Well, 2. 6 divided by 2 is 3. 8 divided by 2 is 4. This simplifies to 3/4. Can I simplify this anymore? No. How about this one? What's a common divisor between 8 and 12? Well, 2 works. 3 doesn't work. It works for 12, but not for 8. And 4 works. 8 can be divided by 4, so can 12. I think that's my greatest one. So I'm going to divide each one by 4. 8 divided by 4 is 2. 12 divided by 4 is 3. 2/3. 2/3 and 3/4 are not equal to each other. So these are not equivalent fractions. Same thing. Simplify them both. Write them and check to see if they're in their simplest terms to see if they're equivalent. 3/9. They both can be divided by 3. 3 and 3. And I get 1/3. These can both be divided by 4. And I get 1/2. 1/2 is not equal to 1/3. This was not equivalent either. Now, if you didn't find the greatest common divisor, let's say you did 2, no fear, no worries. You can go 4 divided by 2 is 2, 8 divided by 2 is 4, and you find another common divisor. Well, these can both be divided by 2. 1/2. You get the same simplest terms. It's just an extra step. But it's sure helpful if you can find that GCD, or greatest common divisor. All right. Write each number as a mixed number. 21/8. I like to think of it as, I like pizza a lot. So I like to think of this as pizzas. The denominator we reviewed in class means how many pieces one whole is cut up into. So this pizza, I just cut it into 8 pieces. And what they're saying is I have 21/8. So that's 8. Now, 8 more pieces would be 16. And then 16, 17, 18, 19, 20, 21. I'm not going to drive the smaller ones. So I have 21/8 is the same as 2 whole, 2 and 1, 2, 3, 4, 5 eighths of a pizza. Okay? So let's go ahead, but mathematically we could do this differently. 21/8 is an improper fraction. The top's numerator is larger or greater than the denominator. So what happens if it's the top's a lot heavier? It tips over. So you write the 21 here and do a fraction. 21 divided by 8, or I'm going to rewrite that. 21 divided by 8. It's kind of what I did here. I took all the 21 pieces and I divided them into groups. Okay, of 8, groups of 8. This is a group of 8, this is a group of 8, and then I had some left over. 21 divided by 8 is 2. 2 times 8 is 16. I've taken care of 16 pizzas. How many left over do I have? 5. So it's 2 and 5 eighths. So 21/8 is 2 and 5 eighths. Let's take a look at 15 here. 16 fifths. Now my pizzas are cut into 5s. 5 pieces make 1 pizza. I can't draw that very well, sorry. So we'll just do it the mathematical way. It's improper fraction. 16 divided by 5. So how many wholes is that? Well, that's 3 wholes. I have 3 whole pizzas and 15 pieces. I'm dividing them into groups of this 16 into groups of 5. I get 3 whole. How many left over? 3 to 15. 1 left over. 3 and 1 fifth. Let's divide into 5 pieces. So 3 and 1 fifth. Okay. Let's move on. Now I write these as improper fractions. So 8 and 2 thirds. So the pizzas are cut into thirds. Or I have to draw a lot. I'm a bad artist. Sorry, guys. So I have 8 pieces and then 2/3 of a piece. So 1/3. Whoops. It's going to be bigger than that. I have 1/3, 2/3, drawing not to scale. That's bad drawing. Okay, so these are all divided into thirds, and they'll have 8 pieces. I can say 8 times 3, right, and get my number. 8 times 3 is 24. Then I have these 2 more here. 24 here. This represents 24 pieces, and 2 more plus 2 would be 26, or 8 whole number times the denominator plus the numerator. This is the 8 times 3 plus 2 more. 8 times 3 is 24 plus 2 more is 26. (26/3). All right, so 25 3/4. This means I have 25 pizzas cut up into 4 pieces. How many individual pieces do I have? 25 cut into 4 pieces. 25 times 4 is 100. Plus 3 more is 103. So whole number times the denominator plus the numerator. 103. 25 times 4 is 100. Plus 3 more is 103. Okay? 103/4. Now I could work the opposite and say 103 divided by 4. I'd get 25 and 3 left over. Okay? So whole number, 7 times 6 is 42, plus 5 more, 47. Denominator stays the same. Okay. 1 times 12 is 12. Plus 7 is 19. 1 times 7, 19 12s. All right. So that should help. We're going to do some more review if you're still having trouble.